The Pythagorean theorem says that if you have a right triangle, then a squared plus b squared equals c squared. Okay, that's what the Pythagorean theorem says. If you have a right triangle, then a squared plus b squared equals c squared. Pythagorean theorem only works with a right triangle. The converse of the Pythagorean theorem says the reverse of that. The converse of the Pythagorean theorem says if a squared plus b squared equals c squared, then you have a right triangle. Okay, I'll say that again just so you get it. The Pythagorean theorem says if you have a right triangle, then a squared plus b squared equals c squared. The converse of the Pythagorean theorem says if a squared plus b squared equals c squared, then you have a right triangle. So the Pythagorean theorem only works for right triangles, means if we can take three sides of a triangle and show the Pythagorean theorem works, that means the triangle must be a right triangle. So in order to test this, in order to take three sides and see, is this a right triangle, we just have to do two things. Thing one, we have to make sure that when we plug the sides into the Pythagorean theorem, that the longest side, the side length that is the biggest number, is our C. A and B don't matter. A and B can be either of the two shorter sides, but C must be the longest side. And we have to make sure that when we plug those three lengths into the Pythagorean theorem, that we end up with a true statement, meaning the side of the equation that has a squared plus b squared and the side of the equation that has c squared are the same number. Let me show you what I mean. Let's take a look at this first example here, where we've got three sides of the triangle, 9, 40, and 41. And what we want to know is this a right triangle? So I don't know if it's a right triangle right now. So I'm just going to draw a triangle. I'm not going to put the right angle symbol on there because I don't know if it's a right angle yet. And the only thing I have to make sure of is when I label these sides, I have to make sure that the longest side, the what I think is going to be the hypotenuse, if this is a right triangle, is the 41. 41 is the longest, so if this is a right triangle, that must be the C. The 9 and the 40, it doesn't matter which one is A and which one is B, as long as those are the two shorter legs. So I'm going to make this one the 9 just because in the picture I drew that side looks a little shorter. So I'm going to make that one the 9. This is going to be the 40, and I'll just call those A and B just because. So now all I'm going to do is see if I plug those into the Pythagorean theorem, do I end up with a statement that is true? In other words, is 9 squared plus 40 squared equal to 41 squared? I have asked you previously to memorize your squares up to 25 squared, which means hopefully you know that 9 squared is 81. You probably don't know what 40 squared and 41 squared are. Those are not squares that you probably know off the top of your head. 40 squared is not difficult though. You just do 4 squared and add a couple of zeros, but it's fine to use the calculator for 40 squared, which is going to give us 1600. And then 41 squared is a little bit trickier than that. You're probably going to want to use a calculator for 41 squared. And 41 squared is going to give us 1681. So the question is 81 plus 1,600 equal to 1,681? And the answer is yes. This side gives us 1,681, which of course is equal to 1,681. So we end up with a statement that is true. 1,681 is equal to 1,681. What this means is those three side lengths that we were given, 9, 40, and 41, those do work with the Pythagorean theorem. And the converse of the Pythagorean theorem says if our three sides work, with the Pythagorean theorem, it is a right triangle. So we could say the sides 9, 40, and 41, and I forgot if we had a unit, inches, do form a right triangle. I can spell triangle. Triangle starts with a T, kids, not with an R. Triangle. The sides 9, 40, and 41 inches do form a right triangle. So if I went back to my diagram now, it would be appropriate for me to add in that right angle measurement now that I have proven this is a right triangle. They do form a right triangle. Okay, let's take a look at a second example. This time we're dealing with meters, 8, 10, and 12. So I'm going to go ahead and sketch out the triangle. I am not going to mark it as a right triangle yet because I don't know if it's a right triangle. If it was a right triangle, though, then I would need to mark the longest side as C. So let's go ahead and make C equal to the 12. That's the longest side. Need to make sure that's going to be the C in the Pythagorean theorem. A and B are going to be 8 and 10, and it doesn't matter which one is A and which one is B. We'll just say A is 8 and B is 10. If you switch those around and say that A is 10 and B is 8, totally fine. Not a big deal at all. So let's do our Pythagorean theorem, which is going to be 8 squared plus 10 squared is equal to 12 squared. And this one is one that you probably don't need a calculator for. It's fine if you want to use one, but you probably don't need a calculator for these squares because you probably memorized these back at elementary school when you memorized your multiplication tables. But use a calculator if you're not sure. So 8 squared is 64. 10 squared is 100. And 12 squared is 144. So now the question is 64 plus 100 equal to 144? And the answer is no. 64 plus 100 is 164, not 144. And that means our three sides do not form a right triangle because this is not a true statement. Turns out, put this in your notes, 164 and 144, not the same number. So the sides 8, 10, and 12, we were measuring meters this time, and 12 meters do not form a right triangle. Because the Pythagorean theorem, or the converse of the Pythagorean theorem, says if the three sides work with the Pythagorean theorem, it's a right triangle. So if the three sides don't work with the Pythagorean theorem, it's not a right triangle.